in SQL, usually if you run the same query two times on the same data, you expect the same result, which makes it easier also to build tests and to validate a query. And with vectors, you may have a different result.
All right. Hello. Welcome back to our podcast for simplyblock. Today, I'm really happy to have a good friend on the call or on the podcast, Franck from Yugabyte. Franck, thank you for being here.
Hey, thank you for inviting me. Yeah.
Absolutely. So, we only have 20 minutes, so let's get right into it. Maybe just say a few words about yourself and Yugabyte. What are you guys doing?
Yeah, quickly, I've always been working with databases and a lot of Oracle, Postgres, and monolithic databases. And I joined Yugabyte as a developer advocate 3 years ago. And it's a distributed SQL database. Basically, the idea is to provide all the Postgres features, but on top of a distributed and storage and transaction engine with the same architecture based on Spanner architecture. So all nodes active, data is distributed, connections are distributed, SQL processing is distributed, and all nodes provide a logical view of the global database.
Right. So maybe just for the people that are not 100% sure what a distributed database is, can you explain a little bit more? You said a couple of different nodes and the data is distributed, obviously.
Yeah. The main reason is that most of the current SQL databases run on a single node that can take the reads and write to be able to check the consistency on that single node. And when there is a need to scale out, then people go to NoSQL, where they can have multiple nodes active, but then missing the SQL feature. So the idea of distributed SQL is that today we can provide both the SQL features, the ACID properties, the consistency, and the possibility to scale horizontally. And two main reasons to scale horizontally: high availability. If you run on multiple nodes, one can be down, the network can be down, and everything continues on the other node. And also to scale, if you go to the cloud, you want more elasticity, you want to run with a small amount of resources and be able to add more resources. With a single database, you can scale up, but then you have to stop it, start a larger instance. When you have multiple servers, you just add new nodes and then be able to handle a higher workload.
Right. So that means what is like the target audience? What is like the main customer profile? Is that data companies with a lot of data, with like high velocity data? What you would say is like the main
For
company?
the amount of data, there are also some users with small databases. I mean, 100 gigabyte is a small database, but they need to be always up, always available.
Mhm.
When you can scale horizontally, you can also do rolling upgrades, rolling patches. So you don't stop the database, you don't stop the application when you upgrade, when you patch the server, when you do a key rotation. So high availability, even for small databases. And of course, the more data you have and you cannot do the backups like with simple PG dumps. If you have a lot of data, you have many constraints to operate it, and makes it easier with the horizontal scalability.
Right,
But
right.
basically, it targets any use case because a SQL database must handle any use case, but it's mostly optimized for OLTP for two reasons: because data warehouses, you don't need all the transactions, so it's easier to shard and without all the ACID properties on data warehouses. And then there are some engines with columnar storage. So Yugabyte is really optimized for OLTP and the analytics query that run on OLTP applications, but not to build a data warehouse.
Right. Okay. Okay. So if I get that right, the two main use cases are like you always have to be up. So a single instance, like I think it's built on Postgres or using the Postgres protocol. So a single Postgres instance, even with like a failover or a secondary, could be a short time not timeout, a short
Downtime.
downtime.
Yeah,
Thank
yeah.
you. That was the exact word I was looking for. A short downtime. So that would be one use case. You cannot justify any outtime or a downtime at all. And on the other side, you have this like massive data sets, but you don't necessarily need a whole transaction around all of that, right? Okay, cool. So what do you think?
So yeah, just to mention, in the case of distributed SQL, you have all transactional properties. So even if you run multi-shard transactions, that's the difference. I made the difference with data warehouses where you may not need that. And you may have some optimization when you don't have all ACID properties. But here, the idea is to have all ACID properties so that you can take an application that runs on Postgres and just run it distributed, maybe with more latency, but higher throughput.
Right. Okay. So the idea is that with Yugabyte, you have the transactional capabilities you would lose when you're going for a data warehouse. Oh, that's interesting. I wasn't 100% sure about that. Interesting. Let me see. What does that mean for users? You can have like you basically can use Yugabyte as a drop-in replacement for a Postgres database, right? Is that it?
In theory, yes, that's the goal. And we
Oh.
use the Postgres codes for the SQL layer. So in theory, yes. There are a few features that are not yet working like in Postgres. When you want to scale out the DDL, for example, Postgres can do transactional DDL. We are implementing that, but when you want it to be scalable, that's different because Postgres allows it, but takes an exclusive lock. And when you build a database that must be always up with the application always ongoing, you have to do something different than taking an exclusive lock for the whole direction of the DDL. So there are a few features that are not there for the moment. There are also some consideration about the data model because data is sharded. You can make some decisions to shard it on range of value or applying a hash value. So there are little things you may think about, but basically the idea is that you don't have to change the code of the application.
Right.
From
Got it.
Postgres to Yugabyte. You may think about the data modeling. If you have a bad design that just works on Postgres, it's always worse when you add some network latency. So you may think a bit more about the good design. Same recommendation, same best practices, but the consequence may be a bit more important when you distribute.
Yeah, that makes sense. I hear you. We had the same thing with a different company we've worked for in the past where it was kind of the same thing. It used the same API, but it worked differently. It had a network layer underneath, and now suddenly everything had a network operation in between or a network transaction in between. And yeah, I hear you. It looks the same, but you still have to think about it a little bit. So when you install Yugabyte, how would you recommend deploying that today? Would you recommend buying like some traditional servers, co-hosting them in a data center, or going into the cloud? I guess I know the answer, but
you can buy bare metal server and install it, but the real value is the elasticity, and then the real value is going in the cloud. Because the point is that when you go to the cloud, if you do the same kind of provisioning, then it will cost a lot. You have an advantage going to the cloud. It can be cost efficient if you can have small instances and add them. So any Linux VM or container can be okay for the nodes. There is no strict. The idea also is that it can run on commodity hardware. You just need network between them, no special hardware, and you can deploy it. There are some users running it on Kubernetes, which is a great platform when you can scale because all pods are equal, so you can just scale the stateful sets. Of course, I will not recommend deploying a database on Kubernetes if you don't know Kubernetes at all. If you have all the application in Kubernetes, makes sense to put the database here. But if it's the first time you touch Kubernetes, probably a database is not the best to start because it is stateful and there are some consideration. But yeah, that's a good platform if you have everything on Kubernetes. Can be also VMs, can be also hybrids on premises on the cloud. That's also the idea. It can be multi-cloud. So that's also an advantage of when you distribute. You can, for example, move from one cloud provider to the other just by adding new nodes and let the cluster rebalance and then removing the other nodes. So yeah, lot of possibilities. The goal is to keep it simple to have everything done by the database. When you scale on Kubernetes, the only command that you do outside of the database is scaling the pods, and then the database will detect it, rebalance the data. The goal is that you don't have to reshard yourself when you do this kind of thing. Yeah.
I found the migration strategy you just pointed out really interesting. Basically, you create a big cluster over multiple cloud providers, and you just scale down bit by bit on the one and scale up on the other, right? So that was at least my understanding. That's an interesting thing. How just from the top of my head, like one question that probably would come up, and you probably had to answer a few times, like, how does Yugabyte handle different sized VMs? Because in this case, there's like no chance you get like the same setup in terms of VMs. Many systems have issues with like differently sized things.
Yeah, really good question. The goal for predictable performance is to have nodes that are kind of equal, and it makes also observability much easier. When you have to start to think about the CPU usage on different instances, that's more difficult. So it's possible to run on different size, but you should consider that just temporary for migration.
Right. Okay. So it's more like a temporary thing, and you have to expect some kind of impact. Meanwhile,
and being hybrid cloud also from a cost point of view, that can be very expensive. If you run a distributed database, there is a lot of data that is exchanged, so it can cost a lot. Makes sense to move from one cloud to the other, running always on two clouds. There are some customers doing that just because they want to be sure that Black Friday they can have enough instances on two cloud providers. But of course, there is a cost behind that. It's more about the agility of changing without stopping the application.
Yeah, I think the biggest cost in that situation would be the traffic between the nodes, right? Because you have to pay for egress, ingress, whatever.
Depends on the cloud provider, but yeah,
even
most
worse.
most of them when you move data from their cloud, you pay a lot. When you move to their cloud, they are happy that you come with more data, so that's fine.
Right. So let me see. What do you think is like the biggest trend you see right now in terms of databases overall? Not specific like relational or I don't know. What do you think is like the biggest star, the biggest new thing that's coming?
I would say long-term trend, I would say simply SQL, because SQL was popular, and then during the NoSQL times, it was not so popular. And now the popularity of SQL is growing again. So I think this is also a trend, considering SQL for many solutions rather than thinking about different databases for different use cases. So that's the general trend. The short-term trend, of course, everybody is talking about vector, PG vector, storing embeddings, indexing embeddings. We'll see what happens. It's kind of a shift in mind for SQL database because we are more used to precise results. And this is more like fuzzy search and maybe, and non-deterministic results. But that comes also with this trend of SQL databases. They are not only for the pure relational data. There are other use cases in them, and yeah, I think vectors like PG vector in Postgres and Postgres compatible databases will be a thing. But yeah, I don't really know about trends. A few years ago, it was all about blockchain and blockchain in all databases, and maybe not.
Right. I hear you. I hear you. I'm also really careful when it comes to like hypes and trends. They come and go. Yeah. So two things on that answer were really interesting. First of all, you said it's all going back to SQL, which kind of reminds me on this like little played with the evolution of NoSQL. Like NoSQL, we don't want SQL. Then it was like all NoSQL, nothing else, and now it's like no, it's SQL. Right? It's I don't remember. It was like 5 or 6 stages. If I can find it, I'll put it into a blog post because the picture is where this plate is just like awesome. So that was the first one. And the second one, right, with vector databases, it was interesting that you mentioned you can't expect like 100% real results, right? And I think that is something we have to learn to work with in the future, especially the bigger the data sets get that we need to analyze, the more important it is to learn to work with, well, let's call it estimates, how good they
Yeah,
are or not are, right?
you can in SQL. Usually, if you run the same query 2 times on the same data, you expect the same results, which makes it easier also to build tests and to validate a query. And with vectors, you may have a different result.
Yeah, which you can do in it's specifically Postgres. I'm not sure about some other databases, but you have this like table, not table spaces, not table space. What do you call it? Like sample space, where you say, okay, take this like massive data set and just give me like a sample
Yeah.
rate of like 10%. That kind of thing happened in the past, and it already gave you like interesting results when you reloaded a web page and the graph was like slightly different. But most of the time you used that when you knew you just wanted to have like a bare overview. You wanted to have
Yeah.
like the form of the graph, not the precise thing, right? And then vector databases goes into the same direction, plus adding some more things on top of that. So that while Yugabyte is a Postgres compatible database, I think PG Vector can perfectly run in Yugabyte, right? You can
So
use that.
PG vector works. The indexes, there is work ongoing. Basically, everything that is at SQL level, extensions at SQL level work on Yugabyte because it's the same code. When it touches the storage, then it must be a bit aware of the distributed storage. We don't store in heap tables and B trees, we store in LSM trees, and then those operations may be different. So today you can use PG Vector, but not the same indexing. And also because you were talking about the different trends, the goal is also not to build a different index for each new trend and to build an index that can adapt. Already in PG Vector, there are, I think, 2 or 3 kind of indexes, and this has changed in less than 1 year. So yeah, better to have something that is flexible enough to be adapted to the different kinds of indexes that will come. Yeah.
I think there is one big difference because you also mentioned blockchain. I think there is one big difference. Here we have a solution to an actual problem, something we want to resolve, whereas I'm not going to bash on blockchain.
No, but yeah, that's
right.
Yeah.
So you said you can deploy it into Kubernetes, and since this this podcast is very well cloud and Kubernetes focused, what do you think is like the worst thing people can overlook when running Yugabyte in the cloud? I think storage is probably a complicated thing.
Yeah, for sure, storage is. The big advantage of a distributed database is that you don't have to share the storage because the database handles that. So you can have local storage, but of course you need also to think about durability and performance. You can run with local NVMe disks on each instance, which will provide the best performance which may be okay for availability, because if you run in multiple zones, you can lose one and everything continues. But if you lose two zones and it is local storage, then you may lose some data. So
Right.
currently, customers run on block storage, like
Mm-hmm.
EBS in AWS, which has the advantage that the storage is persistent. In addition to the high availability of multiple zones, the storage is persistent. Of course, there are some performance considerations, and sometimes the performance reminds me when we were running on a spinning disk a few years ago, because you have the performance, the latency and the throughput limitations of the storage itself, but also each instance, an EC2 instance has a limit. And you can reach also those limits. So yeah, the
Right.
storage is important, thinking about performance, durability, and the agility also, yeah.
Mhm. It's good. You said EBS, and it reminds you of spinning disks, at least not floppy disk. That's good. No, I mean, EBS is a good solution. It's just kind of expensive when you need like high performance storage. And I think that is like the trade-off you have to understand, right?
Yeah.
Yeah, cool. We're at the 20 minutes mark. Unfortunately already. So much more questions. Um, thank you very much for being here. I'm happy to have you back on the show at some point. There's so much more to talk about. And
20 minutes
if you,
is really small, yeah.
yeah, it is. For people having questions, happy to forward questions to Frank. Apart from that, what's your Twitter handle or whatever
Franck
you
Pachot,
use these
my
days?
first name and last name, and yeah, I'm easy to find on Google, and yeah.
All right. Well, we'll put a couple of things in the notes. Yeah, thank you very much for being here. And hope to see you again.
Thank you. Yeah.